Okay, so for 5.4 factoring polynomials, we're going to do GCF, difference of two squares. We're going to do the sum and difference, bless you, of two cubes. And we're going to do factor by grouping, and then we're going to do solving by factoring. So you have done everything but the sum and difference of two cubes. Okay? Your GCF, remember that is your greatest common factor. Bless you. So your greatest common factor is the number or variable that you can divide each term of your polynomial by. Okay? If you're doing variables, remember that it is the term, the variable term, with the lowest exponent. So if you had x to the 5th, x squared, and x to the 7th, my GCF would be x squared. Because of what a GCF is, you're dividing everything by that, so you need the smallest exponent, because when you divide variables, you subtract your exponents. Okay? So when factoring, you're always going to look for the GCF first. So between 3x squared and negative 6x, I need to look at my numbers. 3 and 6, what could my GCF be? 3. And then I'm going to have x squared and x that I need to look at. So I'm going to choose the one with the lowest exponent, which is x. So I'm going to take both terms and divide them by 3x. Now remember that whenever you do your GCF comes out front. And then I divide, 3 divided by 3 is 1, so I don't have to write that. X squared divided by x, I'm subtracting 2 and 1 to leave me with just x. And then negative 6 divided by 3 is a negative 2. X divided by x cancels to 1. So 3x times x minus 2 would be my answer. If you do not write your GCF out front, you're going to lose credit. So make sure you have that as part of your answer. All right, now I have x to the 7th minus 5x to the 6th plus 11x cubed. So if I look at my coefficients, this has a coefficient of 1. So I have 1, negative 5, and 11. Because I have a 1 here, I'm not going to have a GCF between my coefficients. But I do have x to the 7th, x to the 6th, and x to the 3rd power. So my lowest exponent would be x to the 3rd. That's what I'm going to divide by. So x to the 7th divided by x to the 3rd, subtract your exponents and you have x to the 4th. Then minus 5x, 6 minus 3 is going to give me x cubed. And then plus 11, x to the 3rd over x to the 3rd will cancel. Okay. Now, the next example, I have 4x cubed y squared plus 12x squared y minus 20xy cubed. So I'm going to look at my coefficients, 4, 12, and 20. I can divide them all by 4. X cubed, x squared, and x, my lowest exponent is just the x. Then y squared, y, and y cubed, same thing, it's just y. So I'm going to divide all three terms by 4xy. So 4 divided by 4 is 1. X cubed divided by x leaves me with x squared. Y squared divided by y leaves me with y. Plus 12 divided by 4 is 3. X squared over x leaves me with x. Y over y is going to cancel. And then negative 20 divided by 4 is a negative 5. X over x cancels. Y cubed over y leaves me with y squared. Y'all good with that? Taking out your GCF? Okay. So from this point forward, every single example we do, we're going to check for a GCF. Okay? Now, your difference of two perfect squares. You've got to meet a certain list of I guess you could say criteria for it to be the difference of two squares, okay? Now, difference means you have to be subtracting them. 2, there's got to be 2 terms, okay? If you got 3 terms, no longer difference of 2 squares. They have to have perfect square numbers, and your exponents have to be even exponents. They have to be divisible by 2, okay? So your perfect squares, hopefully you know them all the way up to 144, but you've got 1, 4, 9, and then so forth. Do we need to do a whole list, or are you good? You should know 16, 25. I should not have to go further. Okay? You should know it, and if not, just take the square root of the number, and as long as it gives you a whole number in your calculator, that's the perfect square. All right, now your perfect square variables are just even exponents. So x squared, x to the 4th, x to the 6th, x to the 8th, and so on. Okay? So my formula, difference of 2 squares. This is not new. You should know it. All right, if you have a squared minus b squared, it factors to a plus b and a minus b. So it's the exact same thing, just one's plus, one's minus. So what I'm doing is I'm taking the square root of both terms, and that's how I get a, and that's how I get b. All right, so if I have x squared minus 9, I recognize that's the difference of 2 squares. The square root of x squared is my x, and the square root of 9 is my 3. One's plus, one's minus. Okay, and you can always check by FOILing it back out, make sure the middles cancel. You got your difference of 2 squares. Okay, so if I'm looking at the first example, x squared minus 100, is that the difference of 2 squares?
Yes.
Yes. So I'm going to already set up my 2 sets of parentheses. One's a plus, one's a minus. Square root of x squared is x. Square root of 100 is 10. So x plus 10, x minus 10. So anytime you're given a binomial, you're given 2 terms, you only have 2 things you can do with it. You can either factor out a GCF, or you can do the difference of 2 squares. So those are the 2. Anytime you're given a binomial, that's what you go towards. Okay? 9x squared minus 4. Can I take out a GCF here?
Yes. No.
No. Okay, so I'm going to check, is that the difference of 2 squares? Are 9 and 4 perfect squares? Yes. And I have an even exponent, so I can split it. One's plus, bless you, one's minus. Square root of 9x squared gives me 3x. Square root of 4 gives me 2. So 3x plus 2 and 3x minus 2. Okay, then 100x squared minus 1, do I have a GCF? No. So what is that going to factor? 10x. Very good. 10x plus 1, 10x minus 1. Okay, what about 12x squared minus 27? Is that the difference of 2 squares? No. So I need to try to take out a GCF. Between 12 and 27, what can I divide it by?
3.
So I'm going to bring out my 3, and that leaves me with 4x squared minus 9. Now that's the difference of 2 squares. So I'm going to bring down this 3, and I'm going to factor 4x squared minus 9 into 2x plus 3 and 2x minus 3. Now if you do the minus before you do the plus, that's fine too. The order doesn't matter as long as one is positive, one is negative, and you have the right factors there. Okay, now y'all are all flipping, but we haven't even talked about this part. You cannot factor the sum of 2 squares. So if I have x squared plus 9, that is considered to be prime. I cannot make that. That does not equal x plus 3, x minus 3. Okay, you cannot factor that. So it would just be prime. You would leave it as is. You cannot factor it. Okay, that's something you need to know. That's why you only have the difference of 2 squares. Okay? Now, when you get to cubes, it's different. You can have the sum and difference of cubes. Okay, let's talk about our perfect cubes. If I take 1 and cube it, that's 1 times 1 times 1, which is still 1. 2 cubed, 2 times 2 times 2, is going to give me 8. 3 cubed is 27, and 4 cubed is 64. Okay? You can treat these numbers just like you would a square root. If you don't know if it's a perfect cube, you can do it in your calculator. Okay, which I'll show you how to do that in a second. Now, with perfect squares, your variables had to have exponents that were divisible by 2. So perfect cubes, they have to be divisible by 3. So that would be x to the 3rd, x to the 6th, x to the 9th, bless you, and so on. Bless you. Okay? Now, I'm going to take apart this formula. This is your formula for the sum of 2 cubes. I'm going to write out what each term represents. So if you write big, try your best to write small, because we're going to put it all right here. Okay? So if I'm starting with the sum of 2 cubes, a cubed is my first term, and b cubed is my second term. So when I factor it, I've got a binomial times a trinomial. Okay? Well, I have to build the binomial in order to build the trinomial. So to get the binomial going from a cubed to a, all I'm doing is taking the cube root of the first term. And that becomes the first term of my binomial. To get the b, I'm doing the same thing, taking the cube root of the second term. Now the sign just matches your original sign. If I have a plus here, there's a plus here. Once you build this binomial, you're using this to do the second set of parentheses. So I'm done with my original problem. So from a plus b, I'm going to get a squared. So I square the first term of the binomial. Then recognize it switches to a minus. I'm just changing the sign. Okay? This AB, I am multiplying the terms of the binomial. So whatever they are, you're going to multiply the two together. So if it's x plus 3, that becomes 3x. If it's x minus 4, it becomes 4x. If it's 2x plus 3, it becomes 6x. So you just multiply whatever these two are, you multiply them together. Okay? B squared is always going to have a plus because anytime you square something, it's always positive. This will always be positive, whether you have the sum or the difference of 2 cubes. Now b squared, you're treating it like you did a squared. You square the second term of the binomial. Okay? This pattern is really easy. It looks like a lot at first, but it's really easy. Okay? So, if I have my first example, 8x cubed plus 27. If you do not know what the perfect cubes are, and you need to do it in your calculator, you can hit math, and then go down to 4. That's your cube root. So math 4, and then type in your number. So I would say the cube root of 8, which I know it, but if you don't know that, then it gives you your 2. Okay? So 8x cubed plus 27, I know that's the sum of two cubes. I know my factored form gives me a binomial times a trinomial. So I need to take the cube root of 8x cubed. That's my first term. Well, the cube root of 8 is 2. Cube root of x cubed is just x. So my first term of my binomial is 2x. I started with the plus, so I bring the plus down. And then what's the cube root of 27? 3. So 2x plus 3 is my binomial. All I did, cube root, first and second term, there it is. Okay? Now I'm going to use this. I'm going to take 2x and square it. What does that give me? 4x squared. So that becomes my first term for the trinomial. I started with a plus. Now I'm going to switch the sign. It turns negative. And I multiply 2x times 3. And then this is always a plus. And I'm going to take 3 and square it, which gives me 9. There's my factored form. Okay? So x cubed plus 216. I'm going to set up my parentheses. The cube root of x cubed is just x. Bring down your plus. The cube root of 216. Okay. So then my first term of my trinomial, I take x and I square it, which is x squared. Change the sign to a minus. This middle term, I'm taking x and multiplying it by 6, so that becomes 6x. And then this is a plus. And then I take 6 and I square it, which is 36. You're good with that? Okay, try to do number 3. Okay, so 3 and 192 aren't perfect cubes. So I need to take out a GCF. Divide by 3. And that leaves me with x cubed plus what?
64.
Now, that's the sum of two cubes that you can factor when you get back from lunch. Okay? Okay. We factored out the GCF before lunch. Now we have to factor x cubed plus 64. So what am I going to have for my binomial?
Your x plus 4, x minus 4. Oh, no, sorry, I'm still on the other one.
Okay.
And
So
x is x squared minus 4x plus 16.
okay. So took your x and squared it, changed the sign, multiply x and 4 to give you 4x. Then you have plus 4 squared, which is 16. Okay? Make sure you have your GCF out front. That's your final answer. Okay? Now the difference of two cubes, you're going to use that same type of pattern, except now you have a minus. So when you do your binomial, you'll have a subtraction instead of an addition symbol. And so when you go to change your sign, it turns into a plus. But notice that this last term is still going to stay positive because anytime you square something, it's always positive. Okay? So if I have 8x cubed minus 1, I do not need to take out a GCF here. So the cube root of 8x cubed is going to give me 2x. I'm going to bring down the minus, and the cube root of 1 is 1. Then I'm going to use that to build my trinomial. 2x squared is going to give me 4x squared. And then 2x times 1, I change my sign to a positive, and that's a 2x. And then plus 1 squared, which is 1. So as long as you get the pattern down, it shouldn't be too difficult to factor it. Okay? Do number 2, and we're going to check it to make sure you have it down. Cube root of x cubed
X
minus,
5.
okay, then
X squared plus 5x plus 25.
do y'all get that? Do we have questions?
How do we show work for that?
You don't.
Sweet.
So you either get it right or you don't.
You get the real number.
You take
X times 5.
this times this, so x times 5. Here you had 2x times 1. I'm totally fine if you just go straight to your answer. Alright, so this next one I have 27x cubed minus 64y to the 6th. Even though it looks weird, that's still the difference of two cubes. Okay, so the cube root of 27x cubed
It's 3x.
is 3x. The cube root of 64y to the 6th, okay? The cube root of 64 is 4. Now, y to the 6th, all you're doing is dividing 6 by 3. So that's going to give you y squared. Okay, so with your exponents, all you're doing is dividing it by 3. So here, my binomial would be 3x minus 4y squared. And then I'm going to use that to build my trinomial. So 3x squared would give me 9x squared. Change your sign to a plus. So here, I'm having 3x times 4y squared. So 3 times 4 gives me my 12. And then I write my variables in alphabetical order. So it turns into x, y squared. And then plus 4y squared is 16y to the 4th. We're good with that?
Yes.
Okay. Now, factoring by grouping. I'm pretty sure we did grouping with quadratics. Now it's just polynomials. So you're always still going to check for a GCF for all 4 terms. So anytime I give you 4 terms, your only way of factoring it is by grouping. Okay? Just like 2 terms, your only way is GCF for a difference of 2 squares. 4 terms, only way GCF and grouping. Okay? So if I'm looking x squared y plus 3x squared plus 2y plus 6, I don't have anything other than 1 right here. So 1, a 3, a 2, and a 6, I'm not going to pull out a number as a GCF because I have a 1. x squared, I don't have an x in these two terms, so I can't take that out as a GCF. Same thing with my y. I have a y in two of the terms, but I don't in the other two terms. So I don't have a GCF. Sometimes you will, sometimes you won't. Okay? So when you don't have a GCF, you're going to group the first two terms, and then you're going to group the last two terms, and you're going to leave that sign in the middle. Okay? If it's a plus, you don't have to do anything weird. But if there's a minus there, we're going to talk about what you have to do on the next example. Okay, so if I have x squared y plus 3x squared, this is my first group. I'm going to now take out a GCF just with these two terms. So my GCF here would be x squared. And that's going to leave me with y plus 3. Then I have plus. Between 2y and 6, I can take out a 2. And that leaves me with y plus 3. So my whole goal of grouping is to take out your GCF between your two groups, and now I have the same thing inside parentheses. That y plus 3 is now my new GCF that I'm going to take out. So if I factor out this y plus 3, it leaves me with x squared plus 2. Okay, so who's got me? Alright, so the y plus 3 turns into a GCF that I take out. And then x squared plus 2 is what I'm left with. If you do not get the same terms inside your parentheses, you cannot take that out as a GCF. You mess something up with your grouping. Okay? Now, once you get this, you have to check, can I take it any further? Well, I can't do anything with y plus 3. X squared plus 2, I can't do anything either. That's my answer. Okay? I'm pretty positive we did this with quadratics. Or I dreamt that, and maybe, I don't know. X cubed minus x squared minus 4x plus 4. I have 1s as coefficients, so I can't take out a number as my GCF. I have x's in 3 of the 4 terms. I don't have it here, so I can't take that out as a GCF either. So I'm going to group my first two, and I'm going to group my second two. However, I have a minus here. So when you group this, you're really factoring out a -1 to get this negative in the middle. So if you group and you have a minus, you have to change this sign. Whatever the sign is, you have to change it because you had to factor out that negative. Okay? Now you can look, x cubed and x squared. I can take out x squared, and that leaves me with x minus 1. Minus, between 4x and 4, I can take out a 4, and that leaves me with x minus 1 also. So I have the same x minus 1, that's my new GCF. And then I'm left with x squared minus 4. So, can I do anything else with these, or is this my final answer?
I don't know.
You can boil, if you really wanted to, you can boil it.
That's going backwards. Boiling wouldn't get me back to this. So, x minus 1 I can't do anything with. X squared minus 4, what's that? The difference of two squares. So I'm going to bring down my x minus 1, and then x squared minus 4 can factor. Square root of x squared is my x. 1's a plus, 1's a minus. Square root of 4 is 2. So just because we're in the grouping section doesn't mean you can completely forget about everything else. You have to still remember all the ways to see if you can go further. All right, now with 6x cubed minus 18x squared minus 2x plus 6, do I have a GCF here?
Yes.
Yeah.
I can divide them all by
2.
So I'm going to have 2 times 3x cubed minus 9x squared minus x plus 3. Okay, well, I need to factor by grouping. Okay, so I'm going to group together my 3x cubed minus 9x squared, and I'm going to have a minus, so when I group x and 3, what does that turn into?
X minus 3.
There you go, good job. Now I'm doing brackets because we're going to have double parentheses somewhere, so I want to make sure y'all keep that separate. Because of that outside GCF you have to keep. Alright? Now between 3x cubed minus 9x squared, what's my GCF going to be?
3x squared.
So that leaves me with x minus,
3.
and then minus, can I do anything with that x minus 3? No, but I also know I'm going to need something here. If I just have x minus 3, I recognize this is my new GCF, right? So I have my 2, I take out my x minus 3, and that leaves me with 3x squared minus what? 1. Okay? So if you need to put a 1 here so you see a number, you can. But if you're thinking about what you're doing with a GCF, you're just dividing out. So x minus 3 divided by an x minus 3 cancels to a 1. Anything divided by itself is always 1. So that's where this 1 is coming from. Okay? Then I see, can I go any further?
Yes.
3x squared minus 1, 3 is not a perfect square. I can't do the difference of two squares there. This would be my final answer. Okay? So now I'm going to put all this together with what I know, and I'm going to solve by factoring. So the only change that this is making is that it's now an equation. It has to be equal to 0. So every single step, you're going to have equal to 0, or you're going to lose points. Okay? It has to be an equation. You're going to factor it. Once you get factored form equal to 0, then you're going to separate everything equal to 0 and solve for your x values. Okay? So if I look at 3x squared plus 11x plus 8 equals 0, I don't have a section in here in these notes for just a quadratic because you should already know how to factor this. 3x squared plus 11x plus 8, what do? I have a coefficient greater than 1, so I should know to multiply first times last. 3 times 8 is going to give me 24. I need factors of 24 to give me 11. 3 and 8. What are my signs? Both positive. All right, now once I do this 3 and 8, I need to also do what?
Divide both by 3.
Yeah, I multiplied by 3. I got to take it back out, so I divide by 3. And I simplify if possible. Now 3 over 3 simplifies to...
1.
So when we simplify, do y'all remember what I do with this? The bottom takes the x. Y'all remember that? That becomes my coefficient of x for my binomial when I factor. 8 over 3 doesn't simplify. Bottom takes the x. So my factored form is now x plus 1 times,
3x plus 8.
very good, equals 0. So what I do now is I separate and solve. Hopefully y'all remember that. So x plus 1 equals 0. 3x plus 8 equals 0. Subtract your 1, x equals negative 1. Subtract your 8, 3x equals negative 8, so x equals negative 8 thirds. If I wanted to check it, I could take this value, store it for x, type my original, make sure it equals 0. Okay? Alright, 8x cubed minus 6x squared minus 20x equals 0. What do I do first?
GCF.
So 8, 6, and 20 can all be divided by, and then what else? Alright, so I'm going to bring 2x out front, and that leaves me with 4x squared minus 3x minus 10 equals 0. So what I'm looking at now is just what's inside parentheses. So now I've got a factor of 4x squared minus 3x minus 10. That's a quadratic. I'm going to multiply first times last. 4 and 10 is going to give me 40. What do I know about my signs? They're going to be different. One's going to be positive, one's going to be negative. I got to figure out which one's which. Yep. Okay, so when you get your two factors, what factors are going to give me 3? 8 and 5. I know they're going to subtract because they're different signs. So 8 and 5 will give me 3. My larger factor takes the sign of the middle. My middle is a negative, so my larger factor, 8, is going to be negative. Now, when I go to divide, what am I dividing by? 4 or 8? 4, because that's what I'm multiplied by. So I'm going to divide them by 4. Negative 8 over 4 simplifies to negative 2 over 1. Bottom takes the x. 5 over 4 does not simplify. Bottom takes the x. So my full factored form is 2x times
4x plus 5
times
8 minus 2
minus 2.
equals 0.
Now I gotta set how many different parts equal to 0? Do I just set what's in parentheses? I have my GCF also. So 2x equals 0, 4x plus 5 equals 0, and x minus 2 equals 0. So my first set, divide by 2, x is equal to 0. Next one, subtract your 5, 4x equals negative 5. Divide by 4, x equals negative. Then add your 2, x equals 2. What are these x values? I'm solving and I'm getting x equals a number, but what is the significance of these? The what? The zeros and the roots are points on a graph. Which points on a graph describe zeros and roots? The x-intercepts. So when you solve for x values, they're not just random numbers. If I were to graph this, these would be my x-intercepts. Okay? Alright, 2x cubed minus 3x squared plus 6x minus 9 equals 0. Do I have a GCF?
No.
So I'm going to group 2x cubed minus 3x squared. I can take out,
X cubed.
and that leaves me with 2x minus 3 plus 6x minus 9. I can take out, and that leaves me with
2x minus 3
equals 0. Very good. That 2x minus 3, I factor out as my GCF. And that leaves me with x squared plus 3 equals 0. Yeah? Alright, 2x minus 3 equals 0. X squared plus 3 equals 0. 2x minus 3, I can add my 3. 2x is equal to 3. Divide by 2.
X is 3.
Alright, x squared plus 3, I have to subtract 3. So here's the deal. X squared plus 3, I can't factor. If you can't factor, you can either use quadratic formula or you can use square roots. Here, I would do square roots because I have a squared term and a constant. I can move this 3 over. X squared equals negative 3. Take the square root. X equals, when I,
I squared 3.
plus or minus I square root of 3. Okay. Now this next one, 8x cubed minus 64 equals 0. What is this?
Today's cost factor is 8. Well,
You could factor out an 8. So 8 times x cubed minus 8 equals 0. Now what's x cubed minus 8? The difference of two
perfect.
cubes. Okay? So I'm going to have 8 x cubed. I'm taking the square root. That leaves me with x. Bring down your minus. Cube root of 8 is your 2. Then the x squared. Change the sign. X times 2 is 2x. Plus 2 squared, 4. Equals 0. Okay. If I take 8 and set it equal to 0, that's not going to give me anything because 8 is not equal to 0. X minus 2 equal to 0 will give me x equals 2. This x squared plus 2x plus 4. I can't factor this because there's no factors of 4 that will give me 2. So I need to do the quadratic formula. If I could have factored it, I would have factored the very next step before splitting. You factor and factor and factor until you can't factor anymore. Okay, but I recognize that you can't factor this, so we have to do the quadratic formula. So A is equal to 1, B is equal to 2, C is equal to 4. So 4AC is 16. So I have x equals negative
2
plus or minus the square root of
2 squared minus 16 all over 2 times
bless you. So x equals negative 2 plus or minus the square root of, I have 4 minus 16, which is negative 12 over 2. So negative 2 plus or minus the square root of negative 12 simplifies to 2i
2, 3.
square root of 3 over 2. If you didn't know that off the top of your head, you would be doing splitting 12, 2 and 6, 2 and 3. There's my 2 and 3 left over. All right, I need to... All right, so x is equal to negative 1 plus or minus I square root of 3. So if I were to graph 8x cubed minus 64, I would only see it cross at 2. Because these are imaginary, so I won't see them. Okay? But that still gives me my total of 3 x-intercepts that I need. Okay? Okay, 4x squared plus 25 equals 0. They are perfect squares, but I have a plus. So can I factor that? No. It's not the difference of two squares, it's the sum of two squares, which I can't do anything with. So I can either do quadratic formula, or I have a squared term and a constant, I can do square roots. That's what I would do. So you really are not factoring this at all. You subtract your 25, 4x squared equals negative 25. Divide by 4, x squared equals negative 25 over 4. Then I can take the square root. X equals plus or minus. Square root of negative 25 is going to give me over square root of 4 is
2.
all right. 4x cubed minus 4x equals 0. What do I do?
Divide by 4. 4x.
Okay, so 4x times, that leaves me with
X squared minus 1.
Very good. Can I factor that further? Yes. So 4x times, that's the difference of two squares. X plus 1, x minus 1. So 4x is equal to 0, x plus 1 is equal to 0, x minus 1 is equal to 0. Divide by 4, x is equal to 0. Subtract your 1, x equals negative 1. Add your 1, x equals positive 1. Okay? Do we have any questions? Okay, so you're going to have a quiz over this next class on review day. I'm about to pass out y'all's reviews. Just in case you're not here next class, you've got the review. Your test is going to be Tuesday. Okay, because next class, Friday, will be review and quiz. Then after that is test. Okay? If you have questions, come see me. We've got plenty of time to start working. Okay? This lesson.